Okay, so in this video, we're going to talk about the Chapter 10 notes. In Chapter 10, we are basically taking what we learned in Chapter 9 and extending it to the next step, which is going to be solving equations. So in Chapter 9, when we were factoring, we did not have equations, we just had polynomials, just expressions. We could factor them, we could split them up, but we could never say, oh, x has to be this, because we didn't have an equation. But here we're going to have equations, and we're going to talk about two different ways to solve them. Well, really three different ways, but to solve these equations, okay, by factoring, by the quadratic formula, and we'll look at how graphing fits in there as well. Okay, so when we have an equation, so we're looking at something like we see down below in number 1 here. We can see it's x squared plus 5x minus 14 equals 0. It is set up as an equation, and when we have an equation now we can say, well, x has to be such and such in order for this to be true. So we have some steps that we're going to follow here. Let's read through the steps, and then anything that doesn't seem clear will seem more clear as we do an example. So the first step is we want the equation set equal to 0, meaning we want everything else on one side equal to 0. Sometimes that means we have to move things around. We'll factor the side that's not 0. Okay, so depending on what's there, we'll use our factoring methods from Chapter 9. Maybe it'll be a trinomial, maybe it'll be difference of perfect squares, maybe it will be something that we can use factoring by grouping on. Then we set each of those factors equal to 0 using the zero product property. We'll talk about that again in just a minute. We solve for each value of the variable, and then that will give us, x equals 5, x equals 3, whatever it is. And then finally, we'll check our answer. All right, so the zero product property, this is a really important rule. We could not do this method without this rule. And this is one of these rules that you've known for a long time. You just probably don't think about it this formally. Okay, but what I usually do is if I am in a classroom or have a class in front of me, I ask people to give me an example of two numbers that multiply to be 0. So usually I get answers like, 3 times 0, or 0 times 8, or 0 times -1, or 0 times 0. And at some point, someone says, wait a second, isn't any number times 0 equal to 0? And that is true. So if I'm thinking of examples, right, I could say 3 times 0 is 0, or 0 times -5 is 0. And then eventually we generalize that to 0 times any number equals 0. So that comes into play in this case also. Let's say I said to you, all right, what do I get when I multiply 87 times -3.2? Right? Now, you don't know what that is off the top of your head, I would assume. I certainly don't. But we know it's not 0, because not only is 0 times any number 0, but when I multiply two numbers and I get 0, I know there has to be a 0 in there somewhere, right? One of those numbers has to be 0. And that expands beyond just two numbers. If I had 15 students in front of me and they said, okay, we're all thinking of a secret number, and the only thing we're going to tell you, we're each thinking of our own number. The only thing we're going to tell you is that when we multiply all our numbers together, you get 0. Well, then I know there has to be a 0 in there somewhere. So that's what the zero product property says. If A times B equals 0, if two things multiplied, and again, this extends to more, not just two, but in the simplest form, if things are multiplied and they equal 0, then either the first one has to be 0 or the second one has to be 0, or both. There has to be a 0 in there somewhere. So that's our zero product property, and we'll see in a minute where that comes in when we're solving these equations by factoring. And that is, again, if we didn't have that, we would not be able to do this method. All right, so I'm just going to rewrite this just because it's kind of squished up against the question number there. Okay, so we have this. Now, if we think back to our steps, the first step is to set it equal to 0. In this case, we're lucky because we already are starting out there. It's already equal to 0. So now I just factor the side that's not 0. So x squared plus 5x minus 14. I use those factoring strategies. I look for a GCF. There is not one in this case. So I can move on to thinking about which of those formats this falls into. I have 3 terms. It's one of the easier trinomials because there's a 1 in front of the x squared. So I need two numbers that multiply to negative 14 and add to positive 7. Sorry, add to positive 5. I was thinking ahead. So 14 is going to be 1 and 14, or 2 and 7. Those are the only factors. 14 being negative tells me my signs have to be different. 5 being positive tells me there are more positives. So in each case, my larger number is positive and the smaller absolute value becomes negative. And we can see that these are my two numbers that would make both characteristics true. So I have x plus 7 and x minus 2 equals 0. Okay, don't forget that equals 0. So just, you want to think about what the purpose of your problem is. Okay, in this case, we're not just factoring, we're solving for x. So we want to figure out what x is. So we're not done right now. Okay, and this is where this zero product property comes in. So when we think about x plus 7, for example, that really just represents a number, right? If x were 2, it would be 9. If x were 5, it would be 14, 13, 12, whatever. I can't add today, can I? If x were 5, 5 plus 7 would be 12. Whatever this is, this just really represents a number. And same thing with x minus 2. Okay, those each just represent a number. So if the green number times the blue number equals 0, what does that tell us? Well, from the zero product property, that tells us that one of those numbers, or both, but it can't be both in this case, one of those numbers needs to be 0, right? So let me say that again. If the green number, whatever that green part represents, times the blue number equals 0, then one of those numbers has to be 0, okay? So knowing that one of those has to be 0, we're going to set the first one equal to 0 and the second one equal to 0. So this is saying either x plus 7 has to be the one that equals 0, or x minus 2 has to be the one that equals 0. Okay. If x plus 7 were the one that equaled 0, then x would be negative 7. If x minus 2 was 0, then x equals 2. So those are my two answers. Okay, so again, what we did was we said that either x plus 7 or x minus 2, one of those two has to equal 0 because of that zero product property. So what if x plus 7 were the one that equaled 0? Well, then I'd solve x equals negative 7. What if x minus 2 were the one that equaled 0? Well, then I'd solve it and I get x plus 2. So I have two answers, okay? It's not that I have to choose one or the other. It's that both of those numbers make this equation true. Let's go ahead and check this. So just like any other check, we plug in our answer into the equation and make sure that that answer really does make that equation true, make the two sides equal. So we have two parts to our check. First, we check x equals negative 7, see if that works, and then we check x equals 2. You have to check both because it's possible that I would have one right and one wrong. So imagine that when I factored it into x plus 7, x minus 3 by mistake. Then the negative 7 would be right, but the 3 wouldn't, right? So you have to check both of them to make sure there's no mistakes there. So the first part of my check, I'm going to plug in negative 7 everywhere that there is an x, and I'm wondering now if those two are equal. So I have 49 plus negative 35, minus 14. 49 plus negative 35, or you could have written it as 49 minus 35 is going to be 14. 14 minus 14 is 0, so the two sides do equal, so they check. And then I'm going to do the same thing with 2, so I square 2 plus 5 times 2 minus 14 equals 0. This is 4 plus 10 minus 14 equals 0. 4 plus 10 is 14. 0 equals 0, so that checks. So they're both correct. Okay. All right, so let's talk for a minute just about solutions of these higher order equations. So when we look over here at this equation, we see that it had x squared, right? That's the highest degree. So whatever your highest exponent is, that is the maximum number of solutions. So in this case, we're going to have up to 2 solutions, okay? And we did have 2 in this case. If I had x to the third as my highest exponent, that equation could have up to 3 solutions. If I had x to the fourth, that equation could have up to 4 solutions, okay? So let's see why that is for a minute here. Okay, so, sorry, I lost my, okay, sorry, I had technical difficulties for a minute there. So I wanted to show you what this looks like. So if I graph, this red graph right here is the graph that I get when I graph x squared plus 5x minus 14, that equation we just had. And if I zoom in here, and I look at these special places right here where this crosses the x-axis, if you look at those numbers, they might look familiar. That it crosses the x-axis at 2 and -7. Okay, so this is just sort of a bigger piece of information that you need to know, that you can know, which is that the solutions to any equation are the same as the points where it crosses the x-axis. Okay, and so we say that a quadratic equation like this can have up to 2 solutions, because you can see with the parabola that it makes, it can cross the x-axis in 2 places. Now we say up to 2 solutions because look at this blue one. This blue one is still a parabola, but it only crosses in 1 spot. Okay, it just touches and goes back up. And I'll show you what that would look like as factoring also. So then if we look at an x to the third, every time you add an extra exponent, another degree, the graph curves again. So instead of just being a parabola like x squared, it curves again and goes this way. And so you can see that in this case, it can cross in as many as 3 places. If I took this equation and solved it, I would get that my answers were -3, 0, and 1. Okay, x to the fourth. This isn't a great example, but it looks like a W. It can, depending on how curved this part is here. So that can cross in as many as 4 places. Okay. Let me just pick up with a couple things we mentioned there. So if I have x squared plus 6x plus 9 equals 0, and I factor this, I'm going to get x plus 3 and x plus 3, because 3 plus 3 is 6, 3 times 3 is 9. So I have the same factor. So when I solve that, I'm solving the same thing twice, right? So I'm really only going to get one answer. And that's why it just crosses at that 1 point. And the other thing I'd mentioned I was going to show you is x to the fourth equation. Depending on how curvy it is, it can look something like this. There we have 1, 2, 3, 4 points. Okay, not that we'll get into ones like that too much. I mean, a little bit we can if we pull it out as a GCF and things kind of simplify down. But that's just sort of a background. You don't need to be able to explain that, but that's a background on why every higher exponent results in one more solution, or one more possible solution. Okay, so let's try another one, the next one here. So we have x squared plus 7x equals -10. And our first step, remember, is to set this equal to 0. So, and I always move things around in such a way as to leave my highest exponent term positive. Okay, so even if x squared were the only thing on the left and it meant moving everything else over, I would do that in this case to leave my x squared positive. So x squared plus 7x plus 10 equals 0. So I'm going to factor it. I need 2 numbers that multiply to 10 and add to 7. That's going to be 2 and 5. So I have x plus 5 times x plus 2 equals 0. Because of the 0 product property, one of those has to be 0. So I subtract 5 from both sides. x equals -5, subtract 2 from both sides, x equals -2. So those are going to be my two solutions, okay? Now when I check, anytime I check my answers, I always go back to the original equation, the very first version I was given, because if I go back to the one that's equal to 0, I'm worried, well, what if I made a mistake, right? What if I subtracted 10 when I should have added, or whatever? So I always go back to the very original. So first I'm going to check x equals -5. So -5 squared plus 7 times -5 equals -10. So I get 25 minus 35. If I check 25 minus 35 does equal -10. Okay, then I check -2, so -2 squared plus -14 or just -14 equals -10. -2 squared is +4. 4 minus 14 is -10, so that one does check also. And again, I don't give or take off points on the test for showing your check. I take off points if your answer's wrong, so I would suggest checking it, but you can even just plug each side into your calculator and make sure they're equal. Okay, so let's look at this one. I'm going to get you started, and then I would like you to pause the video and finish it up and then come back to check your answer. So this is an example where I said you don't have to do this, but I always prefer to have my highest exponent term positive. So even though going from the right to the left will mean moving two things, I would rather do that to keep my -3x squared positive. So I'm going to add 3x squared to both sides. And I'm just kind of putting it over here because it's not a like term with 18x. And then I'm going to subtract 81 from both sides. And this is 0. And this is 3x squared plus 18x minus 81. So my little suggestion here, my reminder, is to always look for a GCF first. Once you've done that, so just do our normal factoring of pulling out the GCF, having one set of parentheses there. Once you've done that, then take a look at what you have left and factor it again, and then set each factor equal to 0. Okay, so I'd like you to pause it. I'm going to pause mine and do it, so when you pause it and come back, it'll be all done. Okay, I think I'm going to pause it. My computer would like to cooperate.